All right, so now we're going to go ahead and look at the angle addition postulate. It is the exact same thing as the segment addition postulate, except we're talking about angles. So this says if D is on the interior of angle ABC, so that means that we have an angle, and we have points, we have A, B, C, and D is on the interior, so that means that I have another angle in here, and I have D. If D is on the interior angle of angle ABC, then the measure of angle ABD, which would be this one, plus the measure of angle DBC, that would be this one, equals the measure of angle ABC. So it equals the whole thing, which we know from looking at complementary angles in the last video. So let's go ahead and try out a few. So we're going to kind of use, again, our equation knowledge like we did with segments to solve for some of these. So the first thing we're going to do is draw an angle. A, B, you can use whatever variables you want. Just try and keep them alphabetically. A, B, C, and D. I know that this angle is 2x. I know that this angle is x minus 1. And let's say that this whole angle, I know that the measure of angle ABC is 63. Okay, 63. So we're going to go ahead and set up an equation to solve for this. Now I just made up these numbers, so we'll see if we even get nice, pretty numbers, but we're going to go for it anyways. So my angle addition postulate, remember it's an addition postulate, so that means when I add the two together, I should get the total angle. I know the total angle, so I'm going to write an equation to solve for x. So 2x plus x minus 1 equals 63, because I know that the two angles put together equals 63 degrees. So I have these parentheses here, I can drop those. Nothing to distribute, plus x minus 1 equals 63. So I'm going to minus 1, or sorry, plus 1, plus 1. And we have 2x plus x equals 64. 2x plus 1x is 3x equals 64. And now we have to take 64 divided by 3, which gives me 21.3 repeating. So x equals 21.3 repeating. Or we can leave it as a fraction of 64 over 3. Alrighty. So let's go ahead. I'm going to go ahead and give you some to try, and then you can pause the video, work them through, and then you can play it when you're ready to see it worked out. So let's go ahead and give this one a try. And let's see. Right. And then try this one as well. Actually, just, yeah, that's fine. Let's do. All right, go ahead and pause and solve those two problems, and then you can press play when you're ready to see them worked out. All righty, so let's go ahead and work these ones out. This first one does not tell us the angle measure, but it does show us a little box, which means we have 90 degrees. So I know that 3x plus 2x equals 90 degrees. 3x plus 2x is 5x. 5x equals 90. And so then I'm just going to divide 90 by 5. And we get 18. Divide by 5. Divide by 5. X equals 18 degrees. Right, so the angle is not 18, but x equals 18. So now what we could do is go in and find out what these angles actually are. So if x is 18, 2 times x is 36, and 3 times 18 is going to be 54. So now we know what these two angles actually are instead of just x. So it's really important to pay attention to what my problem or what my situation is asking me to do. I might just be finding x, or I might be having to find the actual angle. Let's go ahead and try this one. The total angle measure is 180. So 3x minus 5 plus 2x minus 5 equals 180. I'm going to combine everything first. So I have 3x and 2x is 5x. And then I have negative 5 and negative 5 is negative 10 equals 180. Add 10 to both sides. 5x equals 190. And then we do 190 divided by 5. We get 38. 38. Alrighty, so that is our addition angle postulate. It is just like a segment addition postulate. We use this postulate and our knowledge of algebra to solve for missing angles or missing variables and all of that good stuff. So go ahead and work on your homework next. We'll have a mini quiz tomorrow on this kind of stuff. So go ahead and get started on that, and I will see you back here again tomorrow.